We proceed with the description of the TGA curve. At the first phase, which is the temperature lower or moderate temperature less than 150 degrees C, we can determine that in this range it is loss of the components like water, low molecular weight solvents, or gas desorption process. And for the second phase, which lies between 150 and 250, basically it is loss of low molecular weight compound such as additive, crystallization water, plastifier, or first decomposition product. So if the curve for your material lies between this temperature, you can expect that it contains additive. Okay, it is the temperature or degradation temperature for plasticizer and so on. And temperature between 250 and 500, it is the onset of thermal or inert gas or thermo-oxidative, which is certain content of oxygen decomposition. And the last one is the temperature above 500 degrees C, which is the carbonation of the hydrocarbonated compound, which pyrolysis has no volatile formation related. Main types of TGA curve. Okay, we can see that in the first figure, if your curve is straight, means that no decomposition and the compound is quite stable. If you have a curve like number 2 curve, it is sloped down. It is rapid initial mass loss due to the desorption or the drying. Okay, but we consider it as a stable compound. Okay, if the curve is like this, we have a single stage decomposition, and also the second one, first step in the curve mean one stable product form, and the second dip here we can see that it is a decomposition stage. This one we call it as the multi-stage decomposition, many relatively stable, and it call it as intermediate form. And the fifth graph, it show the multi-stage decomposition with intermediate step, and it is stable product. The stable product are not formed. If your curve like this, which is starting from the earlier temperature, and at the end of the process it gain in mass, so reaction with atmosphere gases means that your sample has react with the gases, either oxygen, nitrogen, or argon. And the last curve can see that it is the increase in mass but unstable product form. Now we look at the example of the product. Okay, we have sample door polymer in small pieces, size about 127 milligram, and we use the temperature 4 degrees C per minute to maximum temperature, which is 900. Okay, rate of heating is 4 degrees C per minute increased to 900 degrees C. So the sample was heated from the room temperature to 900 at a rate of 4 degrees C per minute in air. The TGA curve is labeled in terms of the identity of the components. Here we can see that the polyester, which is 19.7% of the polymer. We have polystyrene, which is 8.1% of the polymer, and also the fiberglass, which is 22.9%, and calcium carbonate, which is 49.3% of the whole, were easily identified by their different temperature of combustion or evaporation. Okay. So from the sample of the door polymer, we can examine what types of material inside this door polymer. So we have 4 compounds, and by using TGA we can know the estimated percentage of this material based on the temperature at temperature of combustion or evaporation. Temperature range from 25 to degrees C routinely. The maximum temperature for TGA can reach is 1000 degrees C. Sample weight can range from 1 milligram to 150 milligram, depend on the types of the instrument and the model. Sample weight of more than 25 milligram are preferred, but excellent results are sometimes obtainable on 1 milligram of the material. Weight change sensitivity of 0.01 milligram. Sample can be analyzed in the form of powder or small pieces, so the interior sample temperature remains close to the measured gas temperature. Now we look at the example of the decomposition of the calcium oxalate monohydrate. Oxalate monohydrate, which is a standard material often used to demonstrate the TGA performance. It during the decomposition process, it exhibits three weight losses with temperature in an inert atmosphere. Use of nitrogen gas. First, it exhibit the weight loss of the water, and the second one for the carbon monoxide, and the last one the release of the carbon dioxide. Okay, this one is the curve for the release of the water, monoxide, and carbon dioxide. Common gases component originating from inorganic material that decompose before the melting point are water, carbon monoxide, carbon dioxide, SOX, NOx. What is SOX? Oxide, sulfur oxide, nitrogen oxide, chlorine oxide, fluorine, and so on. Also, some chemical reaction in solid phase result in gases with weight loss. Okay. So now we look at the factors affecting the TG curve. Factor is the furnace heating rate. If the temperature at which the compound or sample decompose depend upon the heating rate. Okay, if the heating rate is high, so the decomposition temperature is also high. So a heating rate of 3.5 degrees C per minute is usually recommended for reliable and reproducible TGA. Second one is the sample size. Weight of the sample is recommended. Using a small weight will eliminate the existence of temperature gradient through the sample. Also, the particle size of the sample. If the particle size of the sample small, so the particle size of the sample should be small, okay, and uniform size. The use of the large particle or crystal can lead to produce in apparent very rapid weight loss during heating. And also the packing, crucible shape, and also the gas flow rate. Because the shape and the size of the sample holder, it can change the nature of the TG curve. And also for the gas flow rate, it is important to provide the atmosphere inside the furnace so that the compound can be affected of the process of the decomposition process. Pure nitrogen gas from a cylinder it, that will affect either the material will gain or will lose weight at the end of the degradation process. You can use the formula weight percentage equal to weight over initial weight times with 100 if you want to measure the percentage of the mass remaining in the sample after the complete of testing. Okay, this one sample of the compound analyzed by TGA, we can see that the weight loss is about 76%. The percentage of the remaining residue upon the completion of the decomposition is about 11%. Okay, now the graph show the TGA result generated on nylon 66 toothbrush bristle. The plot shows that the percent mass as a function of sample temperature for the nylon 66 bristle under a nitrogen gas. Approximately 10 milligram of sample was heated at a rate of 20 degrees C per minute with the Perkin-Elmer TGA model. So we can see that this unclear picture. TGA show that the nylon 66 polymer undergoes the thermal degradation at 482. So I assume that the 400 is right here. Okay, the curve whereby it start to going downward is the temperature at which the degradation start to occur. So we take the temperature right here. Okay, the reading temperature is on set X, which is 482 degrees C, with a total mass loss of 99%. There is a small amount of the inert residue remaining, which is 0.15% right here. So the nylon polymer absorbs a small amount of ambient moisture, and TGA can be used to determine this level of water. So in the application of the toothbrush, we don't want the toothbrush to absorb the water, right? So what happens if the toothbrush absorb water? You work as a QC department, and if you work in QC department, you will look at the TGA result for the end properties of the product. So in the application of the nylon, you want to avoid the percentage of the water which is high, because the product is considered fail. Because when we use the toothbrush, we don't want the toothbrush to absorb water, right? So we will give totally give a increase of the weight of the sample, and which is fail. Okay, product is considered as fail. The peak in which it detect the presence of water, loss of water, is below 150 degrees C. So at about 56 degrees C, the nylon polymer start to evolve the small amount of moisture, which is found to be 0.86% by TGA. It is here, and a high performance TGA instrument is required to detect this small level of moisture content, because it is less than 1%. Knowing this moisture content is important, as it has a major bearing on the end use properties and processing performance of the nylon. So depend on the application. If the application of nylon 6 is in a toothbrush, so the main focus is in the area between 0 to 150 degrees C. You want to detect the presence of the water or not. So it depends on the QC department and the what we call the parameter they use. What in different in the QC department, it has its own value, okay, to reject the reading of the water. Okay, filler content in polymer. Now we look at the level of the filler can have a significant impact on the end properties of the product. Now we look at the example of the epoxy resin, which undergo the thermal degradation beginning at 450 degrees C with a mass loss of 57.4. At 650 degrees C, the purge gas flowing over the sample was automatically switched to oxygen, and the carbon residue was burned off at 655 degrees C with a mass loss of 10.5%. Now we can see that the curve, we have several multiple curve 1, 2, and 3. The remaining behind after the exposing the sample to oxygen is the inert glass filler, which the TGA shows comprises 35 and 31.8% of the mass of the epoxy resin. So the Perkin-Elmer TGA instrument give all feature the option of an automated gas flow and gas switching accessory for ease of conducting TGA thermo-oxidative experiment. At the temperature right here, it start to degrade at which 440, and then at temperature 600, okay, 600 something, it turns to oxygen, and the residue was burned of 655 degrees C, and we can see that the remaining residue is about 31%. TGA to examine the multiple component. Okay, the compositional characterization information can be enhanced through the use of auto stepwise TGA, whereby